Find roots with the quadratic formula. In this video, we're going to look at using the quadratic formula to find how many roots that a quadratic has or a parabola has. When we're saying roots, it's another word for x-intercepts or zeros or solutions. So if we have, let's say, some parabola that is on a set of axes, we want to find out how many times does it cross the x-axis. This is going to be found by finding the number of real solutions using the quadratic formula. And we will find not only how many there are, but what those solutions are. So we're going to find where does it cross on the x-axis. We looked at some of these in previous videos using solving by factoring. That was always useful when they crossed at whole numbers. Then we looked at solving using a complete the square technique, but the value for a had to be 1 for Algebra 1 level. Now we'll look at using the quadratic formula to find these solutions. Okay, so remember the quadratic formula is given by x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And again, this quadratic formula is always provided to you in Algebra 1. Okay, so solve each using the quadratic formula and state the number of real roots. Okay, so in example 1, we need to first set this equal to 0. Once it's set equal to 0, we can identify a, b, and c. A is 1 because that's the coefficient of x squared. B is 4 because that's the coefficient of x. And c is also 4 because 4 is the constant. Once a, b, and c have been identified, we can substitute into the quadratic formula. X equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times 4, all divided by 2 times 1. So some of these numbers are being repeated because they make up the formula and because both b and c are the same number. Now we can simplify. We'll start by simplifying what's underneath the radical. So we'll have negative 4 plus or minus the square root of, let's use our calculator, and we can type all of it in one shot. 4 squared minus 4 times 1 times 4. And look at that, we get a 0. Right? 4 squared is 16, and 4 times 1 times 4 is also 16. 16 minus 16 is 0. So this makes a lot of sense. So we'll get the square root of 0 over 2. So the square root of 0 is a perfect square. It's just 0. So we'll have x is equal to negative 4 plus or minus 0 over 2. And the interesting thing about this is when our radical turns out to be just 0, it doesn't matter whether we add 0 or subtract 0, we're still going to stay at the same value. So really, we don't need this plus or minus sign, which is interesting because the plus or minus is what creates the two different roots, the two spots where it crosses the x-axis. So if I come over here to finish up, I'll have just x is equal to negative 4 divided by 2, and x is equal to negative 2. So we really only have one root. And visually, if we were to look at a graph of this, if our root is at negative 2, that would be right here on the x-axis. That means this parabola is going to come down and just touch the x-axis at negative 2 and then come back up. So we're not going to cross through the x-axis, we're just going to kind of bounce off it. It's as if the parabola is just sitting right on top of the x-axis, touching only at negative 2. Let's look at example 2. We'll follow the same steps, first setting the quadratic equal to 0. 3x squared minus 2x plus 5, and I have it equal to 0. I can identify a as 3, b as negative 2, and c as 5. Let's use the quadratic formula. X equals negative b. B is negative but I have this negative as part of the formula. So I'm going to have negative the number -2 plus or minus the square root of b squared minus 4 times a times c, all being divided by 2 times 3. Okay, so let's simplify each piece. The negation of -2 is +2. For my square root, I will put all of it into the calculator. I'll have -2 minus 4 times 3 times 5. And that gives me a -62. And 2 times 3 is 6. Now wait a minute. The square root of -62. We know that all numbers that are squared are positive, so taking the square root of a negative number is something that's undefined in mathematics. If I were to take the square root of -62, the calculator says it's an error. It's a non-real answer. And remember, we're trying to find the number of real roots. So if at any time we have a negative underneath the radical here, we're not going to have a real answer. It's going to be what we call an imaginary root. So whenever we get into a situation like this where we have an undefined radical, right here, we'll say no real roots. No real roots. So we've seen in previous videos that we could have as many as 2 roots, 2 times where the parabola crosses the x-axis. It is possible to have 1 root if we're dealing with a perfect square trinomial. You might notice that 4 divided by 2 squared is 4. Or we can have no real roots where we have an undefined parabola. Let's take a look at what this looks like on a graph just to get a visual. If I were to put in this parabola 3x squared minus 2x plus 5 and graph it, notice that this parabola does not cross the x-axis. So that's what we mean when we say it has no real roots. There's no point at which this parabola will intersect the x-axis. All right, let's try some practice. Pause the video here. Use the quadratic formula. See if you can tell how many roots numbers 1 and 2 have. All right, let's take a look. Step 1, set it equal to 0. That means a is -2, b is 7, and c is 4. Using the quadratic formula, we'll have -7 plus or minus the square root 7 squared minus 4 times -2 times 4, all over 2 times -2. Okay, so for here, we'll have -7 plus or minus. Time to simplify the radical. So we have 7 squared minus 4 times -2 times 4, and we'll get 81. Hey, 81 is a perfect square, isn't it? Square root of 81 is 9. 2 times -2 is -4. So since I have a perfect square here, I can put in both the plus and the minus with the 9. So square root of 81 is 9. Now since I have a whole number, I'll split it up into the 2 equations. X equals -7 plus 9 over -4, and x equals -7 minus 9 over -4. We can put this all in at once. -7 plus 9 is 2, divided by -4 will be -1/2. If you leave it as a decimal, that's fine too. And then we'll have -7 minus 9 divided by -4 will be 4. All right, so we have our 2 roots. X equals -1/2, x equals 4. So we'll say 2 roots. So that means this parabola is going to cross the x-axis at -1/2 and at +4. All right, let's give number 2 a try. Set it equal to 0. Identify a, b, and c. Then we can substitute into the quadratic formula. So x is equal to -6 plus or minus the square root, -6 squared minus 4 times -5 times -3. All being divided by 2 times -5. All right, cool. -6 is 6. Now I'll calculate my square root. Let's see, that's going to be -6 squared minus 4 times -5 times -3. Uh-oh, -24. So since I have a negative underneath my radical, remember if we try and take the square root of a negative, it's not going to be a real number. So we'll say no real roots. All right, so this parabola will not cross the x-axis.